Welcome to the beginning of the spring 2024 What Physicists Do series. I'm Professor Scott Severson, and I'm welcoming you here today. I first heard of our speaker, Julia Ruth, via an article in Symmetry, a particle physics magazine produced by Fermilab and SLAC. Her story is fascinating. The merest hint of it seen in her bio on her webpage, which describes her as a performer, coach, producer, and scientist. Her undergraduate degree in physics is from the University of Maryland. She accepted a prestigious National Science Foundation graduate fellowship to pursue geophysics at the Scripps Institution of Oceanography at UC San Diego, where she received her master's degree. The rest of her story is best left to her talk entitled Finding Center, a balancing act between circus and science. Let's give a warm welcome to Julia Ruth.
Great, thank you so much. Thanks, Scott, for that introduction. That was actually way nicer than I expected. You did your research, very impressed. So yeah, my talk is it's gonna be about science, it's gonna be about circus, it's gonna be about bringing those two together, specifically the arts and the sciences. As Scott mentioned, I was a physicist, still am, but climate change scientist as well. And I turned to acrobatics and education more recently. And that's a lot of what this talk is about. So today I want to cover my educational background in a little bit more depth, just so you kind of understand, what got me to where I am today. My past research projects, same thing there. I want to go in detail. I have a very wide range of research that I have conducted. So I want to talk about each of those projects to kind of show all the different types of work that you can do as a student, as a researcher. There's a lot out there. I'm sure you already know that, but I'll go more in depth in each of those projects. I'll, of course, talk about my life as a circus artist. I'll spend plenty of time on this because this is, I think, what's unusual I have found when I give talks to people in academia. I feel like the life that I'm living today is so different than the life I was living as a research scientist. So I want to really give that the attention it deserves. I will show you some videos of my training, of my performances. I always find it's really difficult to explain what I do. It's much easier to show it. And if I'm not there in person able to do my tricks, the best next thing is a video. So we'll see some of that. I do want to talk about the value of art and entertainment, especially if, I remember just being so invested in science that I forgot that there was value to art and a nice connection between art and science. So we'll get that in today, and then I have some takeaways at the end for you. Everyone here, I'm assuming, is coming from different experiences, different backgrounds. So I have developed this presentation with that in mind. So some of this might be something that you're very familiar with, and it's a bit of a review. But ultimately, I hope that you learn a lot through this presentation. Great, so let's jump into first a little bit about me, and then we'll go more in depth with that. So yes, my undergraduate's in physics. I actually did a focus in meteorology, so I took a lot of grad courses in climate science. So that was really cool as an undergrad, actually. I also was in a digital cultures and creativity honors program, so I was doing a lot of computer science and art through the digital world. I then, during that time, spent some time as a research scientist, continuing that work through my graduate program in geophysics, again, more earth science too. I then moved on to being a science teacher, and I continue to be one today. That's been 8 years in running. And I've been performing for 13 years, and 9 of those years have been professional. I don't mind disclosing my age. I'm 31, so a lot of this was concurrent, not all of it one after another, so the numbers add up. This picture on the right here is of me hiking a glacier in Norway, in case anyone was interested. Some of my research was in ice science, so I will go into that. This was actually taken on vacation in Norway, not actually conducting research at the time, but more on this later. So I want to talk first about how I discovered my passion for science. And my passion for science started at a relatively young age. I was in 9th grade, And I actually was attending not high school in the US, but a gymnasium in Germany. So I am German. I lived there for some time. As you can see, my father's a German immigrant. So we went back to Germany for some time. Now, even though my father was a German immigrant, he did not actually teach German to us growing up. So when I moved to Germany at 14, I was studying in a German school, Hermann Böse Gymnasium, and I didn't know any German when I showed up day one. And by the end of that first year, I was conversationally fluent, and still am today, which I'm grateful for. But I did take, ninth grade classes, and that included physics. And what I would do is I would just show up for class, take notes, anything that was written on the board, anything that was shown in a presentation, I wrote down, brought it home for my dad to translate for me, and kind of studied that way. Hermann Böse Gymnasium is a college preparatory school, and college preparatory schools in Germany run from 5th grade to 13th grade, although I think they've phased out 13th grade at this point. But my physics class was my favorite class ever. And I knew that even though there was that language barrier, if I loved it as much as I did through all the extra work I had to do in translating everything, I knew that physics was something special for me. When I came back to the US, I went to a science and tech magnet school for high school. And in order to graduate from this magnet program, we had to conduct a year worth of research, senior year, and we had to write a 6-chapter thesis on that year-long practicum in order to graduate. I will talk about this research on the next couple of slides, but what happened was I actually presented that research as a senior in high school at science fair. And there were some postdocs from the University of Maryland nearby where I went to school that came to my presentation and invited me to participate in research over the summer leading into my freshman year of college in their department, in the physics department under LIGO. So I'll talk about that as well in a couple of slides from now. So my research, senior year of high school, had to do with dark matter, and specifically looking at galaxy rotation curves, understanding whether or not dark matter can be proven mathematically through those galaxy rotation curves. So this is an image from Hubble from the NGC 4414 galaxy. This is just a typical spiral galaxy that we looked at. The biggest observation that we can make looking at this image, and I'm sure you're all realizing this yourselves, it's much brighter in the center than it is as we move outward from the center. So that is key to understanding this next part. And again, if this is redundant for some of you, I apologize, but I just kind of want to get us all on the same page here about this. So we have a graph on the left and this equation on the right. So I'm going to actually draw on this page for just a moment. I'm a very visual person, and I know a lot of other people can be too. So I just want to be mindful of that. If it gives me the opportunity to draw. No, okay, that's fine. So here we can see that, well, G, gravitational constant, that's a constant, but the M is the mass of anything inside of a circular radius. If we're looking at a star that's, X distance from the center, a certain radius, that's what we're talking about. The mass is that center, all of that matter added up on the inside that's contributing to the velocity. And so what we'd expect is that as we go out from the center of a galaxy, that mass is obviously going to increase. We're including more and more light matter within that radius, and the radius is increasing. But because, like I said before, most of the light matter is concentrated in the center of the galaxy and it gets less and less bright as we move outward, that mass, that M, isn't going to be increasing at the same rate as the radius is. So what we would expect then is the velocity as we get further and further from the center of the galaxy to kind of drop, to find this curve that we see in B here. The reality, though, is when we look at actual velocity, we take that data, that information of velocities of stars in a galaxy, we're seeing that they actually follow this A curve. And I'll show you some real data here. This was actually taken by Caltech, but we did a lot of the same calculations. And here we're seeing just a different galaxy, the 6503. And as we move away from the center of the galaxy, our radius is increasing, but we're seeing that velocity sort of level out and be somewhat constant as we move away. So that's the data points here. And we're seeing that, okay, the light matter is contributing to this, but there's got to be something there that we can't see that's also contributing to these velocities. And that we've named dark matter. That dark matter, as we know, is hypothesized. This dark matter halo, which we see in this curve here, is hypothesized right now. And that's just saying that, okay, there's matter there to contribute to that velocity that we just can't see. And if the light matter is decreasing as we get out from the center of a galaxy, well, the dark matter must be increasing. So that's that curve here. We combined the halo, the dark matter halo, with the disk, the light matter, the gas, that light matter. Then we get this ultimate conclusion that the velocity is remaining constant as we travel further from the center of a galaxy. And there are plenty of scientists who are saying, no, it's not dark matter. Dark matter doesn't exist. We haven't been able to detect it. We haven't been able to actually capture it. So maybe there's modified Newtonian dynamics, for example. But the biggest thing that's kind of standing in the way of that is gravitational lensing. And I love this photo. So this, I'm going to tell you later about the classes that I teach to middle school students now. And this is probably one of my favorite images that I show them, because it's this image on the right-hand side, this corner here, but zoomed in to about this region here now on the bigger screen. And what we can see is these, I always call them like squished bug streaks. Like if a bug squishes on your windshield and you run the windshield wipers, we've got that streak. So that's one galaxy that appears to be spread over a vast amount of space because of what we think is dark matter, or something, some matter that's in the way that we can't see, that's causing the light to bend and appear that way. So this has been a big reason why the hypothesis of dark matter has been supported. Like I said, from this project, I was able to transition into a new project, still having to do with astrophysics, but now looking more at gravitational waves, and specifically with LIGO. So I worked in the Department of Physics at the University of Maryland in their LIGO section, the Laser Interferometer and Gravitational Wave Observatory. There are two, this is US based, and there are two. We have one in Washington State and one in Louisiana. And essentially what we're seeing here is these two long arms that actually lasers are sent through. We have a laser that's shot from one direction through a filter, where some of the light continues through, some of the light is reflected to these sensors on the outside, at the ends of those tubes, where that light is then reflected back. And we have this detection screen where those two wavelengths are coming together, the wavelength from each arm. And we have wave interference. So if two waves are in the same frequency, we're seeing that amplitude magnified. If they are equal and opposite, they cancel out. So hypothetically, if we have gravitational waves, and this is how it was explained to me, right? We have these gravitational waves coming to Earth. Our Earth is warping. We're seeing that that changing in the distance of these arms that then change the wave interference, allowing there to be sort of a bright spot and then a dim spot, and a bright spot and a dim spot oscillating. And that's how we know that the Earth is being hit with these gravitational waves. Now, I say that that's how it was explained to me because back when I worked with LIGO, this was before we had ever detected gravitational waves. They were still hypothetical. They were still, we were on this mission to find them. So my project had to do with mapping with MATLAB, actually. So just computer coding here, mapping the parts of the sky that we can see with each given telescope that we have on Earth at any given time, so that if we were to finally detect a gravitational wave, we could immediately understand which telescope can view that portion of the sky, and we can take a snapshot of what astronomical event is happening at that time. So that was before I even started my undergrad. Now, I didn't actually grow up with gymnastics or dance or any kind of performance-based athleticism. And so it was when I started college, that was when I discovered my passion for performance. And the science is going to come back in with this in just a moment. So I joined a gymnastics and acrobatic performance troupe at the University of Maryland called Gymkhana. And that was just me looking for an avenue beyond my studies in physics, beyond my continued research endeavors, to just have something that was fun and exciting, but different. Just something that got me moving, got me exhausted physically because I was already mentally exhausted from everything else. So I had absolutely no experience joining this group. I had played soccer or baseball and volleyball, all these team sports, nothing having to do with gymnastics, and which was great. They said no experience was necessary. But I was awful at first. I mean, I was really bad. I had no idea how to control my body. I had no idea how to flip or nothing. And when my coach found out that I was studying physics, he started to describe what I needed to do in terms of physics. And I trust physics. I think we should all trust physics. And because I trusted it, I understood that if I followed what he was instructing me to do, I was going to land on my feet and, not land on my head, which was probably my biggest concern. I didn't want to perform, actually. I just wanted to train and learn these skills, but it was a performance troupe, so they kind of pushed me into that. And I ended up totally falling in love with it. There's an amazing adrenaline rush that comes with performing and doing the tricks that I do. I felt like I was inspiring audiences, and I felt like my hard work was finally paying off. I had worked so hard to go from nothing to something that being able to show off that hard work was just such a great feeling of accomplishment. So I wanted to keep going with that as much as I could moving forward. But of course, I had to kind of balance the two because I still had this huge passion for science. So as an undergrad, I had more research opportunities. I got to work at the National Aeronautics and Space Administration, better known as NASA, and NOAA, the National Oceanographic and Atmospheric Administration, all while I was an undergrad, and then actually continued with NOAA for some time after undergrad before I transitioned to grad school. Of course, I had coursework at that time too, not just the research. And I was taking a lot of graduate level courses, specifically my junior and senior years of undergrad, especially in the climate science, because that's just how the courses were offered at the University of Maryland. So really challenging stuff, but really exciting and rewarding. It was that same kind of feeling of like, okay, this hard work is paying off. Hard work's paying off physically with the gymnastics, but mentally too with the science. On the side of all that, I'm training gymnastics 3 or 4 times a week. I'm cross training by going to the gym and lifting weights and taking Zumba classes. I was creating acts for the shows. It wasn't just a show up, here's what you need to do. I wanted to create, I wanted to build things to music. I wanted to create costumes. We went on tour in our spring semester, what we call road shows. And every Friday we'd go to a local school and encourage students to be active, physically active, through showing our athleticism. And then we did some shows on campus as well, some halftime shows for our basketball. And then we had a big home show at the end of the year. So I was doing a lot. A big question I get actually when I talk about this is how did I do all of this? I just have a lot of discipline that I learned as a child. And I keep a planner, I keep a schedule, and I stick to it. I write down what I'm going to do every hour of every day, and I follow that most of the time. So that's my little secret about how I juggled all of that. So a little bit about my research at NOAA. Sorry, this is NASA first. I was in the cryospheric laboratory looking at data from West Antarctica, specifically radar data. And this data was not taken by a satellite or by airborne measures. It was actually taken by my advisor at the time, a couple years back, had taken a sled with a radar instrument on it and dragged that sled across the West Antarctic ice sheet for some time. And that's the data we're looking at. And what you'll notice, and you'll see this in the ice core sample on the left-hand side too, we have these layers. We see these stripes through there. And so those layers come from solar radiation. In the summertime in Antarctica, if you're on the peninsula, sure, we'll get above 0 degrees Celsius, but the rest of the Antarctic ice sheet, we're not getting above freezing. but the solar radiation coming in does actually melt somewhat the surface of the ice sheet enough that when it refreezes, it's a little bit thicker. This doesn't happen in the wintertime, obviously, because the solar radiation isn't going to be as strong, but there's a lot more cloud coverage because of the storms that are running through that region. So what I had done with a couple of colleagues of mine was actually create a computer program that was semi-automated in picking out these layers so that then we could analyze and understand how the thickness of the ice sheet has changed over time year by year to understand precipitation levels. So that was really exciting, and it did accumulate in a paper, which I'll have referenced later on in the presentation. And then I moved to NOAA, still working with NASA data for the most part, and actually with some of the same colleagues. The facilities, the NASA facility and the NOAA facility that I worked at in Maryland are very close to each other. They're just a couple of towns away. So it was very easy to transition from one to the other. This now, instead of the Antarctic, was looking at the Arctic, and specifically sea ice. So I'm not looking at any ice sheets, like the Greenland ice sheet, for example, just looking at frozen ocean water, sea ice. And this is an image that I took from the National Snow and Ice Data Center that is from yesterday. They didn't have today's up yet. And this is the extent of the sea ice in the Arctic as of yesterday. So pretty cool stuff that we can get that information readily available right away. But what we're seeing is this downward trend in the surface area, the sea ice extent over time. This is from 1979 when we started taking those observations up until 2022. And we see these seasonal variations, of course, but overall this trend is going down. That surface area is shrinking. What I did with my research was actually look at the change in the ice thickness. So this was research that had been done a lot, the sea ice extent. The thickness hadn't been measured nearly the same extent. So we, together with my colleagues, looked at how the ice thickness had changed over time, still looking at satellite data, but this time laser altimetry. When I went to grad school, I went to the Scripps Institution of Oceanography at the University of California, San Diego. I was in their PhD department, or program, for their geophysics department. As Scott mentioned, I had a National Science Foundation graduate student fellowship. I was also, upon acceptance to the program, awarded a departmental scholarship. And the reason I chose this grad school over the many others that I'd gotten into was that the San Diego Circus Center was there. And the San Diego Circus Center was this beautiful school where I could also train circus, because to me, circus was really the only way I could continue performance in the capacity that I did it as an undergrad. Yeah, so that was a big motivation. San Diego is also beautiful. It's hard to say no to the city of San Diego. So that was also motivation, but it was really the circus that drew me there. The program's amazing. I can't, I wouldn't be able to stop talking about how amazing the Scripps Institution of Oceanography is. But I, of course, as a grad student, had classes. I continued my research. It was optional at the time for my first year in the program, but I had so much fun at NOAA with that sea ice data that I kept going with it, studying for the departmental exams. All of that happened in that first year, as well as training. I tried to fit in at least 3 hours a day, on the weekends a little bit more. I took some time to coach at the circus school as well, and I took every opportunity I could to perform. So again, discipline was really what kept me going through all that. As a graduate student in geophysics, a lot of the research that we did in our classes was with seismology, looking at earthquake data. Real quick, this image on the left-hand side is of the San Andreas Fault, a portion of it where you can actually see this fracture through the earth. Really fascinating to be able to see that with your own eyes. San Andreas Fault is one of the most active fault zones in the world, and it's moving about 5 to 7 centimeters per year, the plates. And so what we were doing was actually measuring that. So here you can see me in the center with a GPS here next to me, where I had put it actually onto a GPS landmark that had been placed there when that what is it called, a wash, I guess, was built. And that metal landmark we would go to every 2 years. When I say we, I mean the department. I was part of that 1 year. Just going, taking that location data, adding it to the data that was taken years before, and understanding how fast the plates are moving relative to each other to better understand if, okay, they're slowing down, then it might be that there's some friction there that then needs to be overcome, and that slip might end up in an earthquake. So trying to gauge when the next earthquake might happen to the best of our abilities, which I think we all know earthquakes can't be predicted at this day and age. So last but not least, one other project that I worked with was looking at INSAR data over various different regions. This one's over the Chihuahuan Desert in Mexico. Basically, this is a method where we had a satellite, for example, here, August 16th, 2005, fly over this region, take data, and then March 14th, a year later, take that same information and compare the two to see how the land has deformed between those two, and trying to watch that deformation to see what might be going on. Obviously, like climate can play a role in that, but we're looking particularly at seismic activity. So again, lots of different research that I was a part of, from geophysics to astrophysics to climate science, lots of different fun projects out there that I got to be a part of. So really exciting. But I ultimately decided to leave the PhD program. This was after just 1 year. The program was actually built in a way so that we could get a master's degree in that first year. And so I did leave with a master's degree, which I'm very grateful for. And I'm very grateful for that year of grad school. I learned so much, and it was so valuable to me. But I had this now or never mentality of, hey, there's this thing in my life that is very physical, and I'm only getting older. We all are, and our bodies are going to adjust because of that. And I felt like I needed to jump into that and take advantage of my youth while I had it, to be able to perform and then come back to science. This is a hiatus. This isn't me leaving forever. I felt really fulfilled by circus because I felt like my research at the time wasn't making an immediate impact. Yes, I was making an impact for sure, but it wasn't immediate. And especially at 22, I felt like I really wanted just immediate satisfaction of, I'm making a difference in the world. And there are research projects out there that do that. I just wasn't part of any. And circus to me was this ability to have an immediate impact in the world. But I didn't want to leave science entirely, and I wanted to have an impact in the world of science. So I turned to education. This was a nice way to still continue to be involved in science, but have that immediate impact and have some time off, summers, for example, to perform. So it was this nice little sweet spot that I had found where I could kind of get the best of all worlds. This is actually a picture of me in my 6th grade classroom doing something that probably, I don't know, any other teacher has done. Just getting a little creative. All right. So as an educator, I spent 3.5 years in the classroom. I taught 6th, 7th, 8th grades, everyone's best years, everyone's just prime time. Physical science, life science, earth, and space sciences were all covered between those 3 grades. I taught at La Jolla Country Day School, which is a private school in San Diego. Honestly, one of the best jobs I've ever had. Loved it. The only reason I left was because I wanted more flexibility in my schedule. I just felt like I was getting these opportunities to perform in Australia, perform in Mexico, like these things that were happening in the middle of the school year, because I was getting away with just summer and winter contracts. And all of a sudden I was getting these other opportunities I just didn't want to say no to. So I continued to teach, but online. And actually I started teaching online before the pandemic back in 2019. I taught first English as a second language at a company called VIP Kid. And I was teaching students in China how to speak English as young as 4 years old, as old as 18. Very, very fun job. Loved working with young children and teaching them English through total immersion. I don't know Mandarin or Cantonese, so it was total immersion. I also taught through Outschool, which is a platform that teachers can create their own classes and it's hosted by Outschool. And so I didn't have to find my own students. I could just kind of put it on the platform and then the students would find me or the families would find me. Taught ukulele classes, taught workout classes, some flexibility classes, so drawing on my own talents and passions. I also taught astronomy, modern physics. Both of those, I have some very popular classes that I have listed on the next slide that just are huge hits for the students, huge hits for me. I love teaching them. And I also teach adults right now in Accent Advisor, and I teach how to speak with an American accent. So I have foreign students that come to me who are fluent in English, but want to speak with a neutral American accent. So that's probably, well, that is my newest teaching job that I've taken on, and it's a lot of fun. So my three most popular science classes that I teach to middle school students online are the dark side of the universe, that's focusing on black holes and dark matter. So some of the research that I had done, I actually bring into that class. I have a class that's for younger students, about 8 to 10 years old, about traveling into a black hole and every stage of the process, what would happen to our bodies if we decided to take a trip into a black hole. And in the process, they learn all about black holes. And probably my most popular class and my favorite to teach is called String Theory, Bringing Quantum Physics and General Relativity Together. And whenever I say this and I say that I teach middle school students, I think people get really confused. And we're not teaching any of the mathematics behind it. It's purely conceptual, but we make it really fun because the world of quantum physics and general relativity is really exciting. And I don't think I need to persuade any of you about that. So it's been a really big challenge for me to take complex material and regurgitate it in a way that a 12-year-old can understand, but I love that challenge. And I feel like it's been very successful. So let me talk a little bit about my life as a circus artist now. So I am a freelance circus performer. So that's different than like a person who's maybe in a resident show. All right, so someone in a resident show might take a contract for 1 year or 2 years, and they're in a show that's in a theater in one place. So for example, my home base right now is Las Vegas. Cirque du Soleil has a lot of resident shows here, and a lot of my friends here have year-long contracts with them and have been working for them for 5 or more years in the same show. For me, I take on contracts that take me elsewhere for the most part and are shorter in duration. Very nomadic lifestyle. In the past 3 years alone, I've lived in 4 cities between the US and Canada. I have moved between 11 different homes. I quite literally live out of suitcases. Those suitcases that you see in the photo there are the suitcases I live out of. I've performed in 16 states in 2 different countries, again, US and Canada. I have no 9-to-5 schedule. It varies every single day, and most of the time I'm working on weekends and holidays, which I love. I know that sounds like a nightmare for some other people, but for me, that's really exciting. So on contract, what does that life look like? So I'm working anywhere from 5 to 10 hours usually on site. It varies so much. Sometimes I have 1 show a day. Sometimes I have 4 shows in a day. I will sometimes work just 1 or 2 days a week, and sometimes I'm working all 7 days a week. I've worked 3 weeks in a row, all 7 days, and 3 shows a day before, for example. Little rough, but then we get the contracts where it's 1 show a day for 3 days a week, and you know it varies so much. But the off days are incredibly fun too, because that's when I get to explore a new place, explore just wherever I am and bond with the other cast members. I'm always working with new people from all walks of life. And so it's just this beautiful opportunity to have ever-changing lifestyle and see new things, go on new adventures. And the adventures are what I live for, that and being on the stage. Off contract happens too, right? I'm not constantly working. I am not working sometimes. I mean, I have my online teaching, but then I spend that time training, anywhere from 2 to 6 hours of training a day, which sounds kind of crazy maybe, but it's not 6 hours of pumping iron in the gym, right? It's time spent working on my specialties, which you'll see in a moment. It's time spent working on my strength or stretching, working on my flexibility. Maybe I have some ailment or an injury that I need to rehab. Maybe I have something that I want to prevent. I don't want to tear my meniscus in my knee, but I'm doing something that's really hard on my knees. I'm going to do exercises to fortify and protect my knee. Physical therapy, athletic training, massage, acupuncture, all part of the job, all necessary for keeping a nice, healthy, working body when we're training 2 to 6 hours a day. I'll sometimes have these gigs here and there where someone will call me up and say, hey, we need you in LA next weekend to do your sear wheel act, which you're going to see in just a moment. That's one of my specialties. And so I'll travel for the day, do my act, get my paycheck, go back home, back to the off contract life. So again, still always changing, always variability, always the hustle. That's the hard part. Honestly, that's the hardest part of this job, is constantly trying to find new work. All right, so I am auditioning in person, I'm auditioning online, sending in my videos, taking new professional videos and photos to promote myself, contacting people. I send emails every single day. And to be quite honest, for every 100 emails I send, I usually get, I'm going to say, about 5 responses back. And of those 5 responses, 4 of them are probably, hey, we received your application, we'll reach out if we need you. So it's rough. But with that rejection comes strength. So it's constantly networking. Most of the work I get actually is through networking, not actually through auditions. I'm creating acts, promoting those acts. I have to use social media to promote myself. I get a lot of work that way as well. That's part of the networking. And I create costumes. I will edit music. There's a lot that goes into promoting oneself, and it's grueling, but it's very exciting, and it keeps me busy, and it makes me a stronger person. So it's not like, oh, I need to interview and apply for jobs. Oh, I got a job. Okay, I have a job. It's okay, I got a job for 1 month. I got to now get the next job for after that month. So a little bit about my specialties. This one's sear wheel. That's how it's pronounced. It is a big metal ring that I spin around in on the ground and do some dance with. I'll show you a quick video here so you can kind of see what that looks like. So as you can see, I have one that lights up. I have a couple that don't. A big question that I get, oh, thank you. A big question that I get is, do I run over my fingers? The answer is no, I have never run over my fingers. So yeah, it's a big metal ring. It is usually steel or aluminum, and has a plastic coating on it so it doesn't slip on the ground. So that's sear wheel. That's my #1 specialty. Oh, we're gonna keep going here to the next slide if it allows me. Okay.
Can we applaud, because that was pretty bad, right?
Thank you. That's really sweet. So I also do hand to hand. I got a few more videos for you, so very exciting. Hand to hand, this is where I'm holding people in handstands, usually tossing them up and catching them, things like that. So that's me actually on the floor holding my partner up, who's the flyer. So I'll show you a couple of clips from my training and performances of that. Awesome. So it's a little bit of hand to hand. Thank you. So yeah, I was on the bottom for all those, and there's one clip where there are three of us in a stack, and I was in the middle for that one. And then I do this thing called Spanish web, which is a rope that I climb to the top of, and there's a loop. As you can see, my hand is in that loop here. The next video is going to show you my foot in that loop, and there's someone below me that's actually holding onto that rope and spinning it very quickly in a circle. So here's the Spanish web. Yeah. All right. I don't know if the sound came through. There shouldn't have been sound. So yeah, yes, is there a question?
Oh, wow, you caught that. That's good. So my daughter does pirouettes and things. I didn't see you like spotting. I mean, you're just spinning. I couldn't, how do you not get dizzy? Like, I was expecting to see your head, you keep hitting certain spots, but I think you were just spinning. Is that right?
Ooh, I am spinning. My eyes are open. I am not spotting. I don't spot for sear wheel either. You build up a spin tolerance over time. And for that act in particular, for the Spanish web, whew, I sometimes, if I get a good spin, which I did in this video, I feel like my eyeballs are going to pop out of my head. But it's part of the job. Yeah. Great question, though. Okay. Finally, I do a lot of stilt walking. I do some puppetry. I do some character work. So you can see that in all these photos. Here I'm on some jumping stilts. Here I'm on stilts with a big flamingo puppet. Here I am at the San Diego Zoo with a big lion puppet. And here I am playing a character in Orange County at a fair there. So I have a couple of clips from some of these on the next slide. Yeah, so that clip at the end was jumping double dutch on stilts, one of my favorite skills that I have done. So lots of fun. And finally, I just want to mention, and I think we all are seeing that all of these demonstrate physics, and they're all a combination of athleticism and artistry. So I'm not just doing big muscly things, I'm also putting on a show. I'm putting on a story. Okay, so that's a big part of the art, and I think there's a big value to entertainment in society, right? Art is a beautiful way to process, either personally or you can process by watching or looking at art. It's a nice escape from reality. It's an invitation to another reality. So you can see on the right hand side, I'm wearing makeup that I designed myself, and that's really to kind of pull you out of reality into another reality. And it's a beautiful way to like inspire people, connect with people. I'm not blind to the fact that we are not essential workers, right? We all lost our jobs March of 2020. But I think that what we do has a strong impact on people's lives, and there is a huge place for art in this world. I actually felt guilty for a long time because I felt like my involvement with circus and with gymnastics was purely selfish. But actually, the more I perform, the more I realize how much I've had an impact on other people's lives. This is through like meet and greets that I've done before and after shows. Like it's really incredible. Circus also has a beautiful opportunity to educate. This is one of my favorite shows of all time. I was not in this show, but I got to watch it before they closed. And this is called Cuisine and Confessions by Les Étoiles de la Main, which is Seven Fingers, which is a Montreal or actually Quebec based company in Canada. And they put on this show with beautiful circus, but it was all about vulnerability and connection because each of these performers told their stories, told their struggles, told their traumas, and connected with each other through those stories all while cooking. This is an actual working kitchen. And at the end of the show, they come around with banana bread that they made. That is the
Mm.
best banana bread I've ever had. So it's this beautiful opportunity to connect with people, to open up people, to provide entertainment and educate people. There's a lot that entertainment can do for us. I find that my success has translated from science to circus and circus to science. So I became a much better public speaker the more I performed, and the more I talk in front of people, the better of a performer I am physically. My communication has improved greatly between those two professions. How I present myself when I apply for jobs, when I'm working a job, the professionalism that I present, I've gotten a lot of feedback on. And I draw that from the science world. I got that from the world of science and academics. And then the teamwork. There's a lot of similarities here. More similarities, actually. Oh, fun fact, a lot of circus performers come from science backgrounds. I have so many friends who are engineers or used to be engineers or biophysicists, or I have a friend who's uh, biology and biomechanics, and I mean the list goes on. So I'm not a unicorn. There's not just one of me. There's higher education in circus. You can get a bachelor's, you can get a master's, you can get a PhD in circus arts at some of these schools. École nationale de cirque and École de cirque de Quebec are both in Canada. The National Institute for Circus Arts is in Melbourne, Australia. Codarts Rotterdam in the Netherlands, Stockholm. They actually have a master's program in contemporary circus arts, and there are more. Tons of higher education in circus. And they don't just teach how to do tricks, they teach the theories behind it, they teach how to research. So, research is a big part of what we do. Oh, here is actually me in the facility for L'École Nationale de Cirque, which is in Montreal, and this is their creation studio. So I got to do a practicum with them and had access to coaches and equipment and artistic counselors, people who are helping me research my act. So, research in the world of circus looks like improvisation. It looks like play. We're just putting some music on, getting creative, being a child, looking through the perspective of a child, maybe, or someone else. Going to other shows, huge. It helps you understand what's out there. It's the same thing as going to other talks and learning about what other scientists are doing. How can you build on what other people have done? No one's creating anything from zero. We're all building on each other. That's amazing. So studying other artists, studying other acts, huge, 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 huge. Uh, we can introduce new elements, new apparatuses through creation, through creativity. We get this. And actually, studying circus history has helped me and a lot of my friends out a lot in that creation process. But it all really is derived from creativity. There, and real quickly here, there's also outreach, and that we call that social circus. And this is a medium for social justice, individual wellness, and it uplifts the role of art and culture in our society, usually to young people in maybe disadvantaged areas. Not always, but that's where a lot of social circus targets. And it's this beautiful way for kids in this case to develop self esteem, solidarity, and trust with one another. So I have a lot of friends who work in social circus, and it's really beautiful the work that they're doing with the community. I want to kind of end with this little quote here from Eleanor Roosevelt. And usually people quote Eleanor Roosevelt and say, do one thing every day that scares you. She actually didn't say that. What she said was this: you gain strength, courage, and confidence by every experience in which you stop to look fear in the face. You must do the thing you think you cannot do. You grow so much from these experiences. What I did was I took a leap. I jumped 2 feet into something, and it was scary. That first leap to leave grad school was so hard, and I had some opposition, but ultimately I had an overwhelming amount of support. The people closest to me could see how much thought I had put into this decision, and they supported me. They understood that I was leaving temporarily and that I was going off to pursue something that I was passionate about and was fulfilling. Yes, I say 2 feet in, but that doesn't mean 100%. It can be, you can still have other interests, right? Like I'm performing, but I'm educating students as well. I do that to keep me sane. I don't think I could do just one thing. And I don't think as human beings we can do just one thing all the time. So this jump, this leap of faith though, it gets easier every time you do it. And I'm constantly taking these leaps every day, and I encourage you to do the same. So with that, I'm just going to end with, well, what does the future look like? For me, I'm constantly reevaluating this. I'm not constantly thinking, do I need to make another leap into something? Do I change what I'm doing? Do I want to keep doing what I'm doing? I keep reevaluating this. I am still learning. I learn languages. I'm fluent in 4, and I continue to keep adding to that if I can and keep working on them. I continue to learn new instruments. I play 4. I'm still taking science classes online. I absolutely love learning. I'm still asking questions. I'm still pushing myself, and I'm continually checking in, setting goals, but having no expectations. And I hope you're doing the same. Here are the references to my 2 published articles, and I just want to thank you all for being here. I really appreciate it. It means a lot to me, and it means a lot to me that I was invited here, so thank you, Scott. And thanks to the Department of Physics and Astronomy for hosting this seminar, so thank you.
Thank you so much. And you gave us time for us to ask our questions, which is great. You probably couldn't hear it on your end, but there were oohs and ahs and drawn in breath with the video. So I will report that. And we're very impressed. But I'm going to open up to the group. I will kind of direct the questioning. But let's start in the back.
Were the videos you showed examples of the kind of things you put out to advertise your skills when applying for jobs?
Yes, yeah, absolutely. So we have demo reels is what they're called when we put together all of the skills and things that we can do into one video and send that out. I will have act videos, and so some of what you saw were portions of my act videos or portions of my demo videos that, yeah, I'm promoting myself with. Some of the photos that you saw are also promotional material.
Yes.
English, German, probably French, number 4, ukulele, and what?
Spanish. I play taiko drums, so Japanese drumming, Japanese flute, the fue. I'm learning Japanese, but I will not tell you I'm fluent in that. And guitar.
With how busy your schedule was, like when you were still in school, did you experience and how did you deal with burnout?
Burnout's real. I'm not going to sit here and tell you that I was just handling it all the time. I was not. I rely on support from my friends and family. I really do. Particularly what I call my chosen family. Because I'm such a nomad, my family is very small and distant. We live all over the country, not even the country, the world. So for me, my chosen family are those friends that I keep very close to me. And I have been very fortunate to have people who are just truly amazing people and amazing people for me and in supporting me. So burnout is so real. I do burn the candle at both ends from time to time, and I try to acknowledge that when I can, catch it before it's too late. And if it is too late, then I lean on the people around me who lean on me in turn. Yeah.
Thanks. I gave a glance at the paper that you did with the radar-based ice study, and for your contribution to that, I was wondering how much coding or computer science experience did you have at the time?
Oh, that's such a good question. So I learned how to code right off the bat with with that thesis that I wrote in at my senior year of high school. And it was mostly MATLAB and Mathematica. And then from there, I did more MATLAB. And then from there, for the NASA with the radar data over Antarctica, that's all MATLAB as well. All coding. 100% of my work with that job was coding. Despite the fact that I love to be physically active, I also love to sit in front of a computer and write code and analyze data. It's something that I'm really passionate about. And I have to say that me having that experience at a young age really put me ahead of a lot of my peers. So if you're, just starting off in, this is to everyone here, if you're starting off in your career as a physicist or as a scientist in general, get computer experience. Even if you're not just starting out and you don't have the experience, like that to me opened up so many doors, and it continues to today.
Have you any injuries that have taken you out of the flow or any programs that you were in the process of?
Yeah. Yeah. Injuries are very real. Before COVID, I actually had never had an injury, and because I take really good care of my body. But being inside and not training the same capacity that I had before, and then jumping into a contract right away as soon as things opened up again, I got injuries. I've never had an immediate injury happen during a performance, but what we call overuse injuries, I have a few of those, or had in the past, that have taken me out of performing and training for months at a time sometimes, and it's a hard thing to do. But again, that community around me is so supportive, because all of my friends who are circus performers also have been injured at some point and had to stop and rest. So we're all there for each other, because we all know how hard that is.
One more.
Do you still stick to 8 hours of sleep a night no matter what?
Oh, I stick to 9 hours a night. I'm a 9 hour a night kind of person, which I have to prioritize it. And it doesn't always happen. But I take my sleep seriously, because the better I sleep, the more productive I am during the day, which makes me tired, which helps me sleep. So it's a positive feedback loop that's really good.
Well, please, let's thank Julia Ruth one more time for a fantastic start to the semester.
Thank you so much, everyone. I really appreciate it.